Hey guys, we're going to walk through a related rates problem here. If you're in AP Calculus, you're probably being tortured by these right now. They are usually word problems. They are hard to set up because it's hard to figure out what you have and what you're supposed to do with it. I have some few easy steps that will help you guide yourself. They still take a lot of practice, but hopefully this will help you out. So if you can read my chicken scratch here, I have my own problem. It says, a cylindrical tank is being filled with water at a constant rate of 2 cubic feet per second. The radius of the tank is 3 feet. How fast is the height of the water increasing? So we have radius, we have volume, we have height of the water, and we have time. So the first thing we're going to do is we're going to do step 1, which is list your ingredients. We have to see what we have. Okay, so let's go through the problem. We have a cylindrical tank, okay, we know it's a cylinder, with water at a constant rate of 2 cubic feet per second. Okay, that's a thing. That's a rate, right? It's a change in volume and a change in time. So we're going to write, we know it's change in volume and change in time. I'm going to write dV dt equals 2. I'll put the unit in here for now. We don't need it later. So there's that. The radius of the tank, that would be helpful. R equals 3 feet. And how fast is the height? I meant to circle that. How fast is the height of the water increasing? So that's our unknown. We'll go ahead and say, what is it that they want to know? They don't want to know the height. We're not going to do H equals. No. Undo. We're going to be like dH, right? Because they said how fast is the height of the water increasing? dH dt, how fast per time? We don't know what it is. Okay, there's some other things that they didn't mention that are still, that we still count as our ingredients. One of them is like volume. Do we know the volume of the cylinder? No. Can we find it out? Absolutely, because we know the radius of the tank. That was awful. So here's radius, here's height. If you don't know how to find the volume of the cylinder, I mean, it's like how many cookies tall is it? A cookie being like the area of the bottom. So you have an area down here, which we all know is pi r squared. Then you just count how many high it is. So it's literally h times pi r squared. Some people like to write it pi r squared h. It doesn't matter. But in our case, because we actually know r, it's going to be pi 3 squared h. So it's, you know, if you want to just write 9 pi h for now, that's fine. And that is pretty much all we know right now. That's all our ingredients that we have. So our next step is going to be to find your recipe. What's our recipe for solving this? So this is the way I like to think about it. Not every teacher teaches it this way, but if I'm trying to find dH dt, that's basically, like, I already have dV dt, so I have my dt on the bottom, which is awesome. So I have something that's going to help me. I have dV dt. And then it's like, okay, well, what's the other thing that I need to find to kind of complete the picture there? I have my dt, but I need a dH here. I need a dH on top. So I need a dH on top, and I need to cancel out my dV. So this is what I need. I need a dH dV. I need, how does the height change with volume? How height changes with volume. And you're like, how the heck am I going to figure that out? Well, guess what? You have a relationship between H and V right here. So that's going to help you. Okay, well, we found our recipe. Basically, we're just going to do dV dt, which we have already from our ingredients, and dH dV, which we're going to figure out. If you do it a different way, it probably actually is this. You probably find dH dV and then like throw the dv/dt on the end. That's how a lot of textbooks and teachers lay it out. Conceptually, it's the exact same thing. It just, I like to lay it out like this because it's way easier to see what the heck is going on. Okay, so we're going to move right into step 3, which is get cooking. We're going to put all this stuff together. So again, our recipe is dH/dt. We already have this dV/dt, which was, what did we say it was, 3, 2? I can't even remember. Oh yeah, it was 2. Okay, and this is what we have to figure out. So we're going to get this. I didn't even write that correctly. Look at that. V. We're going to get this from V equals pi r squared h. Now remember, we want h with respect to v, right? Not v with respect to h. So we got to flip this around. We got to make this equal to h. So we just divide both sides by pi r squared. I mean, it's really that simple. Pi r squared. So h equals v over pi r squared. Oh, wait. I forgot that radius is actually 9. So it's v over 9 pi. Great. So if h equals v, let's call it this. Let's call it 1 over 9 pi. Make that a coefficient by itself, v. Now it's totally easy to derive because it's just a stupid coefficient, and you just do regular derivative junk. So dH dV is just 1 over 9 pi, right? Because if it was y equals 2x, then dy dx would just be 2. Great, so now we have this. Woo! dH dV, plug that in there. Okay, so we're still cooking. dH dt equals, I'm going to plug things in. dV dt we said that was 2. And then now all of a sudden we're saying this is 1 over 9 pi. So we just multiply 2, 2 over 9 pi, which is going to be probably, remember, pi is about 3-ish. So that'd be like 27 on bottom. 2 27ths-ish. Okay, so I never like to end without my 4th step. Cool and serve. Because we need to make sure that this answer is ready to go. We have dH dt equals, let me cut this off over here. Sorry. dH dt is 2 over 9 pi. But what is that? 2 what? 9 pi what? I don't know. Remember, in the problem, here I'll go back to the problem for a second. Remember, in our problem, we said this is feet, this is cubic feet. So everything's in feet, right? So if we go back, that tells us what unit this is, right? dH, change in h, change in height over time. And it was always seconds. So this is 2 over 9 pi feet per second. So the question was, how fast is the height increasing in the cylinder? And our answer is, it is being increased by 2 over 9 pi feet per second. And just for perspective, that's like 2/27ths of a foot every second, which is not much at all. But that's fine. I mean, it's a big tank. It has a radius of 3, which means it's 6 feet across. So, you know, it's not going to fill that fast. So that's what cool and serve is about. Just make sure you have your units right. Make sure they kind of make sense. Obviously, like, I don't expect you to conceptualize giant cylindrical tanks and how fast they fill in your mind, but you know, just be cognizant about it and make sure your units would make sense if you're answering the question and that you're answering the right question. Let's just check that really quick. Did we answer the question here? How fast is the height of the water increasing? And yes, we did answer it. We answered with dH/dt. Awesome. Go do calculus. Have fun.